Hello dear grade 7 children. Today you all are here with me to learn the third lesson of the science textbook, that is generation of electricity. I'm sure there's no need to explain how important electricity is in our day-to-day lives, because we use a lot of instruments, a lot of machines in our day-to-day lives, and most of these machines use electricity. So it is very important to learn how to generate this electricity. There are different methods of generation of electricity. So under this lesson, basically we are going to learn how this electricity is generated. So we will see what are the topics that we have to learn under this lesson. The first topic we are going to learn is sources of electricity. So I told you, basically under this lesson we are going to learn about the different methods of generation of electricity. So we are going to learn what are the different things that can generate this electricity. So under this we are going to learn 3 different sources of electricity. Understand, children? So the next one we are going to learn is direct current and alternating current. So when we learn about this current electricity, which means the electricity we use in our day-to-day life, you will learn that there are 2 different types of current electricity, that is direct current and alternating current. So we will start our work. So there's this assignment we have to do. This is given in the textbook. We will go through this, children. Complete this table which gives information on electrical equipment used frequently. So before I do this one, you all can start to do this, children. Okay. So look at this table. There are 3 columns given. The first column, name of the electrical equipment. So here we have limited space, but when you do this activity, you can write other examples as well. There are many instruments that we use in our day-to-day life. Okay. And the second column, what is the use of that particular equipment and method that electricity is supplied to the equipment. Okay, so we will start this. The first one is given. Name of the equipment, clock. So what is the use? To know the time. And what is the method electricity is supplied? Electric cells. You all know that you have to insert maybe 2 or more electric cells. Okay. Number 2, rice cooker. What is the use of rice cooker? To cook rice. And what is the method that electricity is supplied, children? So in that case, what do you have to use? You have to use the main electrical supply that we get to our houses. That is known as domestic electricity supply. Right? We will write domestic electricity supply. Number 3, headlamp of bicycles. You all have seen some bicycles, they have a headlamp. So what is the use? To get light. Okay. To get light. What is the method that electricity is supplied here, children? You must have seen to these type of bicycles with the headlamp, a tiny dynamo is connected. Okay, so the dynamo provides electricity to the headlight. Okay, we will write dynamo. What are the other examples? We can write fan, electric fan, fan. So what is the use of the fan? Fan is used to get wind. To get wind. And again, what is the method that electricity is supplied? Again, you have to plug this fan to the plug points. It means domestic electricity supply. Domestic electricity supply. the method of that domestic electricity supply produces or generates electricity, I am going to explain later. We have anyway learned this before, even in grade 6. We are going to learn this part later under the lesson. Okay? So, what are the other instances, children? Number 5. I will write torch. Torch is also used to get light. To get light. Okay. So how do we light the torch? Most of the time you can use electric cells. Or some of these torches you can recharge. You can charge them and use. Therefore, either way, domestic electricity supply or electric cells are used. We will write both. I will simply write cells or domestic electricity supply. What are the other instances, children? You can write other examples as well. I am going to write here water heater. Water heater. Now, water heater is used to heat water. To heat water. What is the method that electricity is supplied? Again, using the domestic electricity supply. Right? Domestic electricity supply. Right. Okay, children. So I don't have enough space to write the other information here, but when you do this activity, you can write other examples as well. So when you go through this table, look at this third column, method that electricity is supplied to the equipment. So when you go through this one, you will find there are different methods of supplying electricity. So here electric cells are there, dynamo is here, domestic electricity supply is here. Apart from this, solar cells also can present in some other equipments, like you all have seen some calculators. They work with solar energy. Okay, so that is also one example. So you will see there are many ways that electricity is generated or supplied. Okay, so this happens because there are many sources of electricity. Now we are going to learn what is the meaning of sources of electricity. Sources of electricity. So what is the meaning of sources of electricity? I told you now, electricity is generated in different methods, different ways. Okay, so equipment or appliances that generate electricity are called sources of electricity. It means the things that can generate electricity are simply known as sources of electricity. What are these things or what are these equipment, children? Look at this picture. Only some equipments are given here. Look at what is this. This is a button cell. Button cell. Here can we see these button cells, children? Button cells can be found in some calculators, in wristwatches. This button cell is present. What is this? You must have seen this one. This is a small dynamo. Where can we use dynamo? In bicycles. Even in hydropower plants, we can see different types of dynamos. Okay. And what are these? This is, all of you have seen this one. This is the dry cell. Okay. Dry cells examples, torch batteries, pen torch batteries. Where do we use them? Even the previous example, we discussed that in clocks, in some toys, in torch, we use these type of dry cells. Okay. What is this, children? Have you seen this one? This is a vehicle battery or car battery. The name given to this one is lead acid accumulator. Lead acid Accumulator. Very briefly, it is known as car battery. Why do we call it lead acid accumulator? Because this is made out of lead plates. Lead is a type of metal and an acid called sulfuric acid is present here. Understand? So that is why the combination of lead and sulfuric acid present here. That is why this is known as lead acid accumulator. Okay. What is the last one? This one also you must have seen. This is solar panel. Solar panels. Right. Solar panels also these days a lot of people use solar panels in order to generate electricity. So solar panel is made by the combination of number of solar cells. So if you look at these different types of things which that produce or generate electricity, these are known as sources of electricity. If you look at these sources of electricity carefully, there are different methods that they generate electricity. For example, I told you this lead acid accumulator, metals called lead and sulfuric acid present. Now lead and acid are chemical substances. So due to a chemical reaction, this battery, this is actually a battery. Lead acid accumulator is a battery, type of battery, right? So this battery or vehicle battery can generate electricity because of chemical reactions. What about the solar panels? Solar panels can generate electricity by converting solar energy to electricity. It means the way they generate electricity is different. So there are different sources of electricity, but the way they generate electricity is different. We will see what are these methods now. So electricity is generated by chemical process in some sources of electricity. I already explained you under this one, lead acid accumulator. Right, lead acid accumulator, it has chemical substances. Because of chemical reactions, it can generate electricity. What are the other instances? Even if you look at the dry cells also contain different types of chemicals inside these cells. Right? So because of chemical reactions, some sources of electricity can generate electricity. Right? Electricity is generated by a chemical process in some sources of electricity. There are various chemicals in them. So these are known as chemical cells. The name given to these type of sources of electricity is chemical cells or electrical cells, also correct. Chemical cells. So in the upper grades you are going to learn there are two types of chemical cells called primary cells and secondary cells. Primary cells and secondary cells. Secondary cells. So some of the chemical cells we can recharge and reuse. Okay, those are known as secondary cells. And some other cells are there, we cannot recharge them. They are known as primary cells. So you will learn about these primary and secondary cells in upper grades. Okay. So what are the other examples? Now if you take all the examples for these sources of electricity that generate electricity using chemical process, what are the examples? I already mentioned that dry cells, car battery or vehicle battery or lead acid accumulator, car battery. And there's another cell called simple cell. In grade 6 you have learned about the simple cell. Even this year you are going to learn it, right? Simple cells. Right? So these are the examples for these sources of electricity or things that generate electricity because of the presence of chemical substances. Okay, children? So all these cells, these dry cells, car battery, simple cells, they have chemical substances present inside. So because of the chemical reactions take place, they can generate electricity. Understand, children? Right. Right, children. We have to do an experiment now. So what is the experiment? Examine the contents in a dry cell. So I already explained you dry cell is a type of chemical cell and it generates electricity using chemical reactions. It means it has chemical substances in that, right, inside the cell. So we are going to observe what are the chemical substances present in this cell. So what are the things we need to do this activity? We need a used dry cell. Remember, you should not take a new dry cell because new dry cell, when you cut the dry cell, it's a little moist and you cannot observe the content clearly, right? So you should use a used dry cell. And you need a hacksaw blade, a pair of pliers, a pair of gloves. Why do we have to wear a pair of gloves? That is because I told you there are chemical substances present. Some of them are harmful. That is why you have to wear a pair of gloves, right? And you need a sheet of paper. Remember, when you do this activity, you should not do this alone. You have to get the help of an adult. That is because there are chemical substances that you should not contact with. Okay? We will write this. You will need a used dry cell. Used dry cell. A hacksaw blade. A pair of pliers. A pair of gloves. A sheet of paper. You can take all the chemicals to this sheet of paper. A used dry cell, a hacksaw blade, a pair of pliers, a pair of gloves and a sheet of paper. What do we have to do? In order to examine what are the contents in a dry cell, you have to open this dry cell. You have to cut it using that hacksaw blade. Okay? And you can take out the things present inside this dry cell using the blade and the pair of pliers as well. Okay? So what is the method? The next step of the experiment is write in the method, cut the dry cell longitudinally, it means vertically, right? Using the hacksaw blade and observe the longitudinal section of the cell carefully. Now we will go to the lab and do this activity. Now we are going to examine the contents in a dry cell. So you all know dry cell is coming under a chemical cell. So how does this generate electricity, children? By chemical reactions. There are different chemical substances in this dry cell. So because of the reactions of those chemical substances, it can generate electricity. Understand? So when you take this dry cell, you will know that there are two terminals. What are the two terminals? Positive and negative terminals. So this is the positive terminal. Okay, and this is the negative terminal. Right, children? So this is the externally, this is how it appears. I am going to cut open one dry cell now. So I have already opened one part of the dry cell. See, now this is this cap-like structure. Okay, which was here. And this is the outer cover, outer metal cover. And after that metal cover, we can see a polythene cover over here. Right. We need to remove that polythene cover as well. And this is the cover of the negative terminal, this side. Right. I am going to open this one. Now this is another metal cover, children. This metal is the zinc metal. So in this dry cell, zinc acts as the negative terminal and carbon acts as the positive terminal. Now you all can see this black color paste-like substance present here. Now this is already a dried cell. This is an old cell, children. So if it's a new cell, it's a usable one. this present as a paste. Now it is already dried and it present as a powder, thick powder, right? I'm going to open it now. You all can see from here the black color rod-like structures there. See what happens. Okay, now it's all dried up, because with time some chemical substances in this dry cell, they are consumed during production of electricity, generation of electricity. Therefore, it's already dried. But if the cell is in a good condition, it is moist and it present as a paste. So when I open this one, you can see this is a black color powder. This is a mixture of manganese dioxide, ammonium chloride and carbon. So all these things are chemical substances, children. So during generation of electricity, these chemical substances react with each other. Okay. So you can see this rod, this black color rod, it runs throughout the cell. Okay, so this is the carbon rod. This carbon rod acts as the positive terminal and the zinc acts as the negative terminal. Understand, children? Right. So this is that carbon rod, children. Totally taken out. This is the same rod present like this. This is that one. So it is covered with this plastic cap, and that plastic cap after covers with this type of structure. Okay. So this is the zinc case. Completely removed zinc case. So when the cell present like this, this carbon rod present inside the zinc case like this, and in between this paste present, chemical substances. So I hope it's very clear now. Did you observe what I was showing you, children? So there were many chemicals present in the dry cell. Now you don't need to memorize the names of these chemicals, but I explained you. There are different types of substances present inside the dry cell. Do you remember? There was a carbon rod like this, right? There was a metal cover like this. And there was a paste-like substances, I told you, manganese dioxide, ammonium chloride and carbon present in that mixture. So observations, there were many chemicals present in the dry cell. We will write. You don't need to memorize these names, okay? Many chemicals present in the cell, in the dry cell. Okay, so what is the conclusion? Conclusion is also the same. Dry cell consists of different types of chemicals according to this activity, right? Dry cell consists of different types of chemicals. Right, dry cell consists of different types of chemicals. So we discussed there are different types of things or sources that generate electricity, and they generate electricity in different ways. Now we discussed about chemical cells. Using chemical reactions, they generate electricity. And some sources generate electricity by rotating or moving them. What generates electricity by rotating or moving, children? Have you seen how a small dynamo is fixed to the bicycle? You all have seen this dynamo, a bottle-like structure. It is fixed to the bicycle as this lid-like structure. It touches the wheel of the bicycle. So when you ride the bicycle, what happens when the wheel rotates? This bottle-like structure also rotates. Dynamo is connected to the headlamp. Remember, only when you ride the bicycle, the headlamp lights up. The reason behind this is when you ride the bicycle, as this turning part of the bicycle dynamo is connected or it contacts with this tire, this part also rotates. It means it moves, right? Only when that part moves, it can generate electricity. We are going to do experiments to study this one, okay? So, only when this part rotates or moves, this bulb lights up, okay? It means this dynamo generates electricity by rotating or movement. Understand, children? So, some sources generate electricity by rotating or moving them. Okay, so what are the examples? So, here dynamo. And another example is generator, right? Generator is also another example. Understand, children? We are going to study about these dynamos and generators later in the same lesson. Okay? Right. So, equipment that generate electricity can be grouped as given below according to the way they generate electricity. So, what is the name given to the thing? So, equipment that generate electricity, they are known as sources of electricity. And I explained that sources of electricity, they generate electricity in different ways. Okay, so based on the way they generate electricity, we can divide all these sources under three main groups. Okay, so what is the first group? Electric cells and batteries. So how do they generate electricity? Do you remember I explained you about the car battery or vehicle battery and about dry cells? I told you they use chemical substances to generate electricity. It means using chemical reactions, these type of sources generate electricity. Okay, and number two, dynamo. We learn about the dynamo. How do these dynamos generate electricity? By rotating or moving. Okay, and the third group is solar cells. We all know that solar cells generate electricity by using solar energy. Okay, we will write these things. Electric cells and batteries generate electricity by chemical reactions, right, children? Chemical reactions. Dynamos generate electricity by rotating or moving. Generate electricity by rotating or, I will write the slash, rotating or moving. And the third group is solar cells. Solar cells generates electricity by using solar energy. Understand? Equipment that generate electricity can be grouped as given below according to the way they generate electricity. Electric cells and batteries generate electricity by chemical reactions. Dynamo generates electricity by rotating or moving. And solar cell generates electricity by using solar energy. It means all the sources of electricity or the things that generate electricity, there are three main groups based on the way they generate electricity. Electric cells and batteries, dynamos and solar cells. Understand, children? We have to do another experiment to understand these things better. So when we study about the cells and batteries, there's this very important experiment that we all can do. What is the experiment? Generating electricity using a lime fruit. So we are going to prove that a lime fruit can generate electricity. So what are the things we need to do this experiment, children? We need a lime fruit and we need a copper sheet and a zinc sheet. Now copper and zinc both are metals, right? You need a small copper sheet and a small zinc sheet. And you need some pieces of wires, right? And then you need a milliammeter or a galvanometer. So milliammeter, galvanometer you can use to measure small electric currents. We will write down this one. A lime fruit, copper sheet, it's brown in color. Zinc sheet, it is silver in color, right? The zinc sheet, pieces of wire, a milliammeter, or a galvanometer. Right. So how to do this activity? We are going to study this under the method part. Right. So under the method here we have the label diagram, right? So you have to take the lime fruit. You can see the copper sheet, zinc sheet, and this is the milliammeter or the galvanometer also can be used, right? So what is the method? First of all, you have to take the lime fruit and you have to press it thoroughly. Why do you have to press it thoroughly, children? Now lime fruit has, you all have seen, if you open this lime fruit, if you cut it into two halves, you will see these structures are there. Okay, it is divided into room-like structures. So in these structures, you have seen tiny pocket-like structures present. Okay, so inside these pocket-like structures, there's an acid called citric acid. Citric acid. Now we need to take this citric acid out of these pocket-like structures. What is the reason, children? Now we are going to prove that this lime fruit can generate electricity because of the chemical substances present in that. So the chemical substance is citric acid. So we have to take it out of these pocket-like structures. But you should not press this lime fruit too hard. Okay, only you have to press it thoroughly, but that lime juice should not come out of the lime fruit. Okay, so press the lime fruit thoroughly. Understand? And insert the pieces of copper sheet and zinc sheet into the lime fruit without contacting each other as given in the diagram. You can see copper sheet and zinc sheet are inserted to this lime fruit, but they should not touch each other. And then you have to connect these pieces of wire to each copper and zinc sheets. Okay? Connect the free ends of the wires to the milliammeter. Now, these free ends of the wires you have to connect to the milliammeter. And make sure copper sheet and zinc sheet should be taken as positive and negative terminals. You all know when we discuss about cells, they have positive and negative terminals. Okay? So, for now you can go through this one like this. Copper sheet is the positive terminal, zinc sheet is the negative terminal. Therefore, when you connect this copper sheet, this wire with the copper sheet should be connected to the positive side of the milliammeter and zinc sheet should be connected to the negative side of the milliammeter. And you can observe what happens to the indicator of the milliammeter or the galvanometer. Right? What you have to do again? You have to take the lime fruit. you have to press it thoroughly, and you have to insert these copper and zinc sheets with wires to this lime fruit without contacting each other. And then you have to connect the free ends of these two wires to the milliammeter or the galvanometer, and you have to check whether if there's any movement of this indicator. Understand? We will go do this activity now. Now I'm going to show you that we can use a lime fruit to generate electricity. So what do you need to do this experiment? We need a lime fruit and a center zero galvanometer, and we need 2 sheets of zinc and copper. So I already connected the zinc and copper sheets to the 2 terminals. Okay children, so this is the negative terminal and the positive terminal. So center zero galvanometer, we have 0 mark in the center, and this galvanometer we can use to measure small amounts of electric currents. Okay, so first of all, before we start this experiment, we have to press this lime fruit thoroughly. So why do we have to press this lime fruit, children? So you all know that there are sac-like structures in the lime fruit. So these sac-like structures contain lime juice. So we have to take this lime juice out of those sac-like structures. So why do you have to take this lime juice out, children? Because lime juice contains a chemical substance called citric acid. Okay, so I'm going to show you that lime fruit can act as a cell. It's a simple cell. So you all know that chemical cells, they act using the chemical reactions. So this citric acid acts as a chemical substance here. Okay. So now after pressing this thoroughly, you have to make small slits in this lime fruit. I'm going to make 2 slits like this. Right. And then I'm going to put this zinc sheet to one side. Now you all have to observe what happens to the indicator of the galvanometer, children. You all can see the indicator is in 0. So carefully observe what happens when I insert this zinc sheet to this lime fruit. So you all can see earlier the indicator was in the 0. Now you all can see as I connect this one, it deflects, it moves. So you all have studied in grade 6, the galvanometer can move its indicator or deflects its indicator only if electric current passes through this. So earlier when these 2 terminals are not connected, you know that this indicator was in the 0 level. But what happens when I connect these 2 terminals, these 2 sheets into this lime fruit? The indicator moves. It means when I connect these 2 terminals, it starts to generate electricity. Electric current passes through the galvanometer. That is the reason that indicator moves away from 0 level. Okay, so it is very clear lime fruit can be used to generate electricity. What actually happens here is, at this moment the lime fruit acts as a simple cell. I hope you remember in grade 6 you learn about this simple cell. Simple cell is made by the similar structure, but instead of lime fruit we use dilute sulfuric acid. Okay children, so anyway we are going to learn about the simple cell later. So I hope you understand this one very well. Right children, did you observe what happened? What happened when that copper sheet and zinc sheet were connected to the galvanometer we used? What happened to the indicator of the galvanometer? It deflects. So it's very clear that electricity is generated in the lime fruit. How do we make sure that electricity is generated? Because the only instance that milliammeter or the galvanometer indicator moves is only when electricity passes through it. Right? So you observe very clearly that when I connected these copper and zinc sheet and those wires to this milliammeter, what happened children? This indicator moves. It means when we connect this lime fruit, all this setup to the milliammeter or galvanometer, it generates electricity and that electricity passes through the instrument. So it's very clear this apparatus made with the lime fruit can generate electricity. Understand? We will write down observations. The indicator of the galvanometer, you can even use millimeter, deflects or moves. Right, indicator of the galvanometer, millimeter deflects when the apparatus is connected to it. We will write that part as well. When the apparatus is connected. Okay, so what is the conclusion? I told you the only instance this indicator of the galvanometer, millimeter deflects or moves only when electricity passes through it. Therefore, this lime fruit can generate electricity. We will write. The indicator deflects only when electricity flows through the galvanometer. Therefore, the apparatus or the setup apparatus made with the lime fruit generates electricity. Understand? The indicator deflects only when electricity flows through the galvanometer. Therefore, the apparatus or the setup made with the lime fruit generates electricity. So next I am going to explain you about the simple cell. You will realize this setup made with the lime fruit and the copper sheet and the zinc sheet, it is somewhat equal to the simple cell. So here what happens, copper sheet, zinc sheet and citric acid present in this lime fruit all are chemical substances. So because of the chemical reactions take place between them, electricity is generated. Understand? So you will realize this setup acts as the simple cell. Now we have to do another experiment, that is construction of a simple cell. So we are learning about electric cells or chemical cells. I explained that simple cell is also a type of chemical cell. It means it uses chemical substances to generate electricity, right? So how to do this experiment? We will see what are the things we need. We need a beaker. We will write each. Beaker. And we need a copper sheet. Copper sheet. And we need a zinc sheet. Zinc sheet. We need a bulb and a bulb holder. Bulb and bulb holder. And a small motor. And copper wire. copper wire, and we need an ammeter here. Ammeter. Then we need sulfuric acid, dilute sulfuric acid. So earlier during that experiment with the lime fruit, I told you we used copper sheet, zinc sheet, and what was the acid present in the lime? That was citric acid. So because of the chemical reactions take place between copper sheet, zinc sheet and the citric acid, electricity is generated. Here we are going to use a different acid, that is dilute sulfuric acid. Dilute sulfuric acid. Okay, and we need some pieces of wire. Pieces of wire. Understand, children? So how to do this activity? We will go see in the method. Right. Look at this one. Look at the experiment. We have to construct a simple cell using this dilute sulfuric acid in the beaker, copper sheet and zinc sheet connected to wires. Right. So now if you consider the simple cell, you are going to learn this is the simple cell. This is the dilute, I will write short form, dilute sulfuric acid, and we have to use the copper sheet, and the zinc sheet. And basically, this is the wire, and basically this is our structure, the basic structure of the simple cell. Okay, dilute sulfuric acid in a beaker, zinc sheet and copper sheet immersed in this dilute sulfuric acid, and you can connect different components in between these pieces of wire and observe what happens. This is what we are going to do in this experiment, right? So these are the ways that you can connect them. Okay, so clean the copper sheet and zinc sheets thoroughly and connect a piece of wire to one end of each sheet. So you can clean these two sheets with a piece of sandpaper. Understand? And dip copper and zinc sheets into the acid without letting them come into contact with each other. Right? When you immerse these two sheets, zinc and copper sheets, they should not touch each other in the acid. Understand? Then connect the torch bulb to the free ends of the wires and observe what happens. We have two wires here. You have to first connect a torch bulb. Okay? And then connect the center zero ammeter to the free ends of the wires. In this one, it's given bulb and ammeter connected at the same time, but you can connect separately as well. Okay, so you can remove the bulb and you can connect a ammeter, center zero ammeter to this one, right? And then connect the small motor instead of ammeter and observe. Okay, you can remove the ammeter and you can connect a small motor instead of the ammeter. Understand? And wind the copper wire around plastic rod and connect this coil. You can take this copper wire and you can take a pen and you can wind this copper wire around the pen and make a small coil like this. Right. Now you can connect this coil of wire to these two ends of the wires and you can check what happens after a little while. Okay, so it's very clear each time as the basic setup you use this simple cell. Okay, the first instance you connect a bulb here and then you remove the bulb and connect an ammeter here and then you remove the ammeter and connect a small motor and then you remove the small motor and connect the coil of wire made with copper wire. Okay, So after connecting them, you have to observe what happens. Understand? Now we are going to do this experiment in the lab. Right, children? Now we are going to construct a simple cell. Now simple cell is a type of a chemical cell. You all know that chemical cells generate electricity by chemical reactions. It means they contain chemical substances. When these chemical substances react with each other, they generate electricity. So I will show you how we can construct a simple cell. Now here we have a beaker filled with dilute sulfuric acid. Dilute sulfuric acid is considered as one chemical used in the simple cell. And we need a copper sheet and a zinc sheet. Now this silver color sheet is the zinc sheet. This copper color, brown color sheet is the copper sheet. Okay. So by connecting this copper sheet and zinc sheet, we can construct this simple cell. So first of all, I am going to check this simple cell with a bulb. So what I have to do is, we have to immerse these two sheets in this dilute sulfuric acid. And remember, these two sheets should not touch each other. So that is why these two sheets are kept away from each other using a block of wood. Okay. So observe carefully when I immerse these two sheets in this dilute sulfuric acid, what happens to the bulb. Okay, children. So these observations will last only for a very short period of time. Therefore, you have to observe carefully. Can you all see, children? The bulb illuminates, but the brightness is very low. The bulb illuminates with a very weak light. So when I remove these two sheets from the liquid, it goes off. When I insert it again illuminates. But this time it's weaker. Now you all can see, even though the two sheets are immersed in this liquid, dilute sulfuric acid, what happens? The bulb does not illuminate. Okay. So in that case, I am going to show you what actually happens inside the beaker. Can you all see there are tiny air bubbles around the zinc sheet, children? So because of these air bubbles gather around the zinc sheet, it cannot generate electricity anymore. Therefore, we have to take this out, clean these two sheets using water. Now this is water. So after cleaning this, I am going to wipe it very well. We'll check again with the sulfuric acid. You all can see. This time it illuminates again, but a very weak light. So after a little while you will see it will go off again. So this is how the simple cell functions. You can't obtain a continuous flow of electricity. That is because of accumulation of these tiny gas bubbles. Okay, children. So this is one disadvantage of this cell at the same time. Okay, children. Now I am going to show you the simple cell with a ammeter. Now this is the ammeter. You all can see this is the 0th level. Indicator is at 0 now. It means electricity does not flow through this ammeter. The ammeter indicator moves only if electricity flows through this one. Okay. So here we have the copper sheet and zinc sheet connected to this one. First I am going to put one terminal. See what happens to the indicator. So when I immerse the next sheet, copper sheet, you can see this indicator deflects. Now when I take it out again, what happens? It goes back to 0. I will immerse it again. You can see the deflection of this indicator. It deflects only when electricity travels through that. Okay. So it means when we immerse these two sheets in the sulfuric acid, what happens, children? Electricity generates. Okay. So now I have connected this coil of wire. This is a copper coil. I have connected this coil of wire to the simple cell. So in order to function this simple cell, you all know that you have to immerse this zinc sheet and copper sheet in this dilute sulfuric acid. Okay. So let's see what happens. So when you immerse this, remember children, they should not touch each other. So because we use a coil of wire, not like a light bulb, you won't be able to see anything. But after a little while, I am going to observe what happens by touching this. So you all can observe what happens inside the beaker. So you all can see this in this zinc sheet, how gas bubbles emit in this zinc sheet. So children, when I touch this coil of wire, I can feel it's getting heated up. So that would be the observation. You can't see any emission of light because this is not like a light bulb. But when I touch this one, I can feel it's slightly hot. So what happens here? Electricity is generated. When electricity passes through this coil of wire, it gets heated up. Right, children? Now we have to connect an electric motor to the simple cell. Remember, the electricity generated by one simple cell is not enough to work this motor. Therefore, this time I am going to use two simple cells connected together. So here we have two sets of these sheets, zinc and copper sheets, and two beakers with dilute sulfuric acid. Understand, children? Here we have the motor. In order to observe the rotation of the motor, I am going to connect this propeller-like structure so that you can observe this clearly. And now I am going to immerse these two sets of sheets in sulfuric acid. See what happens? It starts to rotate. There was only a slight rotation, children, because the electricity generated by the system is not very big. That's why. So it's very clear now. When you use this dilute sulfuric acid with a zinc sheet and a copper sheet, it acts as a simple cell. Right, children? So you saw what happened when we connect different equipment or different components to the simple cell. Okay. So what were the observations? First you connected these observations when the bulb is connected. What happened when the bulb is connected, children? The bulb lights up. The bulb illuminates. Okay, we will write it. Bulb illuminates. Illuminates. And observations when the motor is connected. What happened, children? The motor rotates, right? Motor rotates. And observations when the coil is connected. Now you could not observe anything, but I told you when I touch the coil, it gets heated up. Okay, it is hot when I touch it. It means when the coil is connected, what happens? The coil gets heated up, right? It gets heated up. And observations when the ammeter is connected. What did you see when the ammeter was connected? What happened to the indicator, children? It deflects, right? We will write indicator, indicator deflects. Right? Observations when the bulb is connected, the bulb illuminates. Observations when the motor is connected, motor rotates. Observations when the coil is connected, it gets heated up. And observations when the ammeter is connected, indicator deflects. And what are the other observations? You all saw that gas bubbles are formed, right? gas bubbles formed. And what is the other special observations? Did you see any of these observations for a long period of time? So what happens after connecting the bulb? It illuminates only for a short period of time. Even the motor rotates for a short period of time, right? Even the indicator deflects for a short period of time. It means these observations do not last for a long period of time. Understand? So we will write that as well. Any other observations? Gas bubbles form and observations last for a short period of time. Short period of time. Okay, gas bubbles form and observations last for a short period of time. Understand? So what is the conclusion? So we constructed the simple cell and we connected the simple cells to the bulb, the motor, the coil of wire and the ammeter. Okay. So you saw different observations. The bulb lights up, motor rotates, the coil gets heated up and the indicator of the ammeter deflects. Why do these things happen, children? That happens because of generation of electricity. The indicator deflects only if electricity passes through the ammeter, right? So the coil gets heated up only if electricity passes through the coil of wire, right? The motor rotates only with the presence of electricity. Even the bulb illuminates or lights up only with the presence of electricity. It means the simple cell generates electricity. Okay, we will write the conclusion. The simple cell generates electricity. Right? The simple cell generates electricity. That is because it can generate electricity, all these observations were possible. Understand? We have some information here. Center zero ammeter. Now there are two different types of ammeter called. Now normal ammeter, you will see the indicator in a corner like this. When electricity doesn't flow through the ammeter, right? Now this is 0 and it goes on 1, 2, 3, 4 likewise, right? What about the center zero ammeter and even center zero galvanometer? They are the indicator present like this. 0 is present in the center. Okay? So this indicator can move to either side. Understand? So an ammeter or a milliammeter and even a galvanometer with 0 at center, is used to detect the amount as well as the direction of electric current. So we are going to learn under this lesson, there's a special direction to the flow of electricity. Okay, so based on the direction of current, the direction where this indicator move to is different, changes. So when the direction of the current changes according to the direction of the current, this indicator in this center zero ammeter, it can move to either side. Therefore, you can identify the direction of the current as well using this type of instrument, right? So, an ammeter or a milliammeter with 0 at the center is used to detect the amount as well as the direction of electric current flowing through the conductor. Okay, an ampere is the standard unit to measure electric current. SI unit or standard international unit of measuring current is ampere. Right, ampere. Symbol is capital A. But apart from this ampere, in order to measure small currents, we can use milliampere as well as a subunit. Okay, so the subunit milliampere is also used to measure small current. Okay, but the main or SI unit of measuring electric current is ampere. Symbol is capital A. Understand, children? Right. Okay, now we have a setup made with 3 simple cells. Construction of a system of simple cells. What is a simple cell? We already discussed about this. Simple cell is made by dilute sulfuric acid, and 2 metal plates immersed in this dilute sulfuric acid. What are the plates? Zinc sheet and copper sheet. So in between these pieces of wire, you can connect a bulb or ammeter, likewise. Okay, but look at this one. 3 simple cells are connected together. What is the way it is connected? You can see now this is the copper sheet. Right, and this is the zinc sheet. When you consider the second one, this is the copper sheet and zinc sheet. And this is the copper sheet and this is the zinc sheet. Okay. So what is the way it is connected? Look at this one. Zinc sheet of the first cell is connected to the copper sheet of the second cell. And the zinc sheet of the second cell is connected to the copper sheet of the third cell. So copper and zinc sheets are connected each time. Okay. So this is a setup constructed by 3 different simple cells. And you can even increase the number. What will happen? Now you can see 2 wires are taken from each side. Right? This free copper sheet and the free zinc sheets are connected to 2 pieces of wire. Now let's say if you connect a bulb between A and B, what will you observe? Now if you connect the same bulb to this single simple cell, you will see it will light up, it will illuminate. But what will happen if you connect the same bulb to this setup? Now we have 3 cells connected together. What can you tell about the power or electricity supplied by this setup? Obviously, it is higher than that of the single simple cell. Okay, so you will see if you do the same experiment we did before with 3 simple cells together, you will see this bulb will glow brighter. Okay, the bulb will glow brighter. What will happen if you connect the motor to this one? Motor will spin faster, right? It will rotate faster. What will happen if you connect the ammeter? The ammeter indicator, it will deflect more than the first setup. Okay, so what will happen if you connect a bulb? Bulb will glow brighter, right? Bulb glows brighter. And motor, if you connect a motor, it rotates faster. And ammeter, what will happen? Ammeter, indicator, deflects more. movement will be more than the single or one simple cell. Okay, so if you connect a coil of wire, it will get heated faster than before. Understand why does this happen, children? Now there's a certain amount of electricity supplied by one simple cell, but when you use this setup with 3 simple cells, it will obviously supply more power, more electricity. So when more electricity flows through these equipment, they will work better, right? So bulb glows brighter, motor rotates faster, and the ammeter indicator deflects more. It all indicates that more electricity is supplied by 3 cells. Understand, children? Right. Right, children. The next experiment we have to do is construction of a battery. What is a battery? Now you all know that in our day-to-day life, we call this structure a battery. What we use in different toys or clocks, what we use, this part is the battery. But now you all know, I explained that this is a dry cell. It's a type of cell. So what is a battery, children? If this is not a battery, day-to-day life we call this a battery, but actually this is not a battery in science. This is a cell. This is a dry cell. So what is a battery? I will explain this. You know how we constructed this setup. Now this is a simple cell, one unit. So we constructed this setup using 3 simple cells like this. Understand? This is a type of battery. So what is a battery then? A battery is made by combining 2 or more cells. This is a cell, this is a battery. Cell is only one unit, battery means combination of 2 or more cells. Okay, children. So this battery is made by combining simple cells. Okay, we will move to our experiment. Construction of a battery. We are going to make a battery using dry cells now. So in order to do this activity, we need several dry cells here. Okay, and some pieces of wire, a piece of cardboard, and some rubber bands, or even sellotape is also okay. Right? We will write down these things. Several dry cells. Pieces of wire. Pieces of wire, cardboard, and rubber bands. You can even use sellotape. So how to make a battery using this equipment? We will go see. What is the method? Look at this one. You have to make a structure like this. You can use 4 dry cells and you can connect them with each other as given here. Connect 4 dry cells as shown in the figure. What is the method? You can say this is the positive terminal, negative terminal. And this side is now, if I label this one, cell number 1, 2, 3, 4. It's very clear. The negative terminal of the second cell is connected to the positive terminal of the first cell, right? And the negative terminal of the third cell is connected to the positive terminal of the second cell. And the negative terminal of the fourth cell is connected to the positive terminal of the third cell. So that is the method that you have to connect these cells. Okay. So from the free ends, you have to connect 2 pieces of wire. Understand? So what is the method? Connect 4 dry cells as shown in the figure. Rubber bands or sellotape can be used to connect wires to dry cells. And what you have to do, wrap the set of dry cells around using a piece of cardboard. Now using the cardboard, you can do that. Right? Wrap the set of dry cells round using a piece of cardboard to make it a handy pack, so easy to use it when you cover it, right? And take out the terminals from the pack and connect different components. You can check by connecting a light bulb or a motor or an ammeter likewise. Okay, children. So first we can do the experiment with a single dry cell with one cell, and next we can do the experiment with using 4 dry cells or a battery. Now this is a battery. Understand what is a battery? Battery is made by combining 2 or more dry cells. Now this entire setup is a battery. Okay, children. So we can connect different components to these free ends. So we will do the experiment now. Now we are going to study the function of a cell and a battery. Now you all know that dry cells, these are the single units. Now remember, in day-to-day life, we call this one a battery, right? But this is only a single unit. I am going to show you what a battery means and what a cell means. Now this is a single unit and this is known as a cell. Now this is the dry cell. So we will see what happens. Now I am going to connect this to this setup, and I am going to connect this dry cell to this bulb. So you all can see the bulb illuminates, but the brightness is not too high. Its brightness is weak. Okay, children. Now I am going to use a setup made by connecting several cells. Now here you all can see there are 4 cells connected. Now this is one cell. You can see this is the negative terminal and this is the positive terminal. So the negative terminal of the second cell is connected to the positive terminal of the first cell, right? So this is the negative and positive. And when it goes to this side, you can see this cell's positive terminal is connected to the third cell's negative terminal. Okay, children? And this positive terminal is connected to the negative terminal of the fourth cell. So this type of series is known as a battery. Okay, children? So in day-to-day life, we call this one unit as a battery. Even though we call it a battery, remember, in science, we learn that this one piece is known as the cell. Collection of several cells are known as a battery. Okay, children? So I will show you what happens when we connect the same light bulb to this battery. So I'm going to, now this is the negative terminal and the positive terminal. Right. Look at the brightness, children. Brightness is very high than the previous instance. Earlier we used only one cell and now we used several cells, 4 cells. So this type of combination is known as a battery. So in your day-to-day activities, there are instances that you have to use a higher amount of electricity. So in that case, instead of using a single cell, we can use a collection of cells which is known as a battery. Right, children. So you watch the experiment. What happened when I connected this bulb to one cell? The brightness was weak. Okay. But what happened when I connected to our battery, combined with 4 cells? The brightness increases. Why does this happen, children? That happens because when you take a single cell, one dry cell, only a certain amount of electricity is supplied, right? But when you increase the number of cells connected in the battery, what happens? More power, more electricity is supplied. That is the reason the brightness increases. Okay, we will write that. Observations. When the bulb is connected to the battery, the brightness of the bulb brightness of the bulb increases. Right? When the bulb is connected to the battery, the brightness of the bulb increases than it is connected to a single cell, one dry cell. Right? What is the conclusion? What is the reason behind this? Because the battery supplies more electric current than using a single cell, one dry cell. We will write that. A battery supply more electric current than a single cell. A battery supplies more electric current than a single cell. Okay, we have self-assessment to do. This is given in the textbook. We will go through this. Mention 3 weaknesses of simple cells. Now, simple cells are constructed with dilute sulfuric acid and a copper plate and zinc plate immersed in this dilute sulfuric acid. What are the weaknesses, children? Is it portable? Can we carry it here and there easily? It's not. That is because it contains a liquid. Right, children? So, that is the first weakness of simple cells. Right? It's not easy to handle. Right? It's difficult to handle. That is because it contains a liquid. What are the other things? Do you remember while I was showing this experiment, I had to clean these 2 plates immersing in water. Why does this happen? That is because of the deposition of gas bubbles. Gas bubbles are formed and they deposit in these plates, and so then you have to take out the plates and you have to clean them again. It means because of the formation of these gas bubbles, we can't obtain a continuous flow of electric current. What is the third weakness, children? Third weakness is, even if the cell doesn't work properly, from the moment you immerse these 2 sheets, copper sheet and zinc sheet, in this liquid or the dilute sulfuric acid, the zinc plate or zinc sheet starts to dissolve rapidly. Okay, that is the other disadvantage or the other weakness. Therefore, even though the bulb connected to the cell is not working, it doesn't light up, but still the zinc plate will rapidly react with the acid. Understand? So, we will write these disadvantages. So, the weaknesses. Number 1, difficult to handle. Difficult to handle as it contains a liquid. As it contains a liquid. Right? Number 2. Formation of gas bubbles. Gas bubbles disturbs the continuous flow of electricity. What is the third one? I mentioned that zinc plate dissolves rapidly. Zinc plate dissolves rapidly. Mention 3 weaknesses of simple cells. Difficult to handle as it contains a liquid. Formation of gas bubbles disturbs the continuous flow of electricity. Zinc plate dissolves rapidly. Understand? Number 2. Write an advantage of a battery compared to a cell. It's very clear after doing the previous experiment. We can obtain more electricity from a battery. Okay, we will write that. Write an advantage of a battery compared to a cell. More electric current can be obtained from a battery than from a cell. And from a cell. Understand? More electric current can be obtained from a battery than from a cell. Give examples for instances when cells and batteries are used in day-to-day life. Now, I am pretty sure you can write many examples for this. What are the instances? We will write some of these examples, children. What are the instances where you use these cells and batteries? There are many examples. In clocks, watches, what else? Vehicles, in remote controllers, What are the other instances? Cameras, in toys, mobile phones, etc. You can write many examples as you like. Okay, children, there are many instances we use cells and batteries in our day-to-day life. We have another question. Today, simple cells are not in use because of some weaknesses in them. What are they? We already discussed these weaknesses, right? What are the weaknesses? We wrote all these weaknesses. What are they? Difficult to handle as it contains a liquid, right? It's not portable. Just think about a dry cell. Dry cells can be taken here and there very easily. Okay, that is because it doesn't have a liquid like in a simple cell. But simple cells, there is a liquid, dilute sulfuric acid. Therefore, it's very difficult to handle, not easy to handle. Right? What is the second weakness? We discussed that formation of gas bubbles disturbs the continuous flow of electricity. So, time to time, you have to take out the copper sheet and zinc sheet and you have to wash them with water and you have to clean them again and immerse it in the acid. So, it's very difficult. That it happens because when you use this cell for a certain period of time, gas bubbles are formed and it blocks the flow of electric current. Okay. What is the third one? Zinc plate dissolves rapidly. So, then when this zinc plate is over, you have to replace it with a new zinc plate. That is the other weakness. Okay. So, because of all these weaknesses, nowadays we don't use the simple cells. We will write it. Number 1. Cannot obtain a continuous flow of electricity due to formation of gas bubbles. Right. Number 2. zinc plate dissolves rapidly. Number 3, difficult to handle. Difficult to handle due to the presence of a liquid. What is the liquid, children? Dilute sulfuric acid. So, cannot obtain a continuous flow of electricity due to formation of gas bubbles. Zinc plate dissolves rapidly. Difficult to handle due to the presence of a liquid. These are the weaknesses of simple cells. Because of these weaknesses, we can't use it. Now, these simple cells are not in use because of these weaknesses, right? That is why nowadays we have switched to dry cells and other cells. Okay, we have some more information here. Information on several types of cells and batteries available in the market are given below. This is additional knowledge, but we will go through them. This is really important, right? So, what are the different types of cells given in this column? And what are the materials? And what are the instances of uses is also given, right? So, number 1, dry cells. We all know what dry cells are. So, what are the materials? I showed you when during that experiment when I showed you how to open a dry cell and what are the substances present. What are the things present? Zinc sheet, carbon rod, carbon powder and other chemicals like ammonium chloride, manganese dioxide, etc. Okay. And what are the instances? Used in torches, radio sets, some radios, okay. In wall clocks and some toys, we use these type of dry cells, okay. Alkali cells, metals like nickel and cadmium, alkaline components are used as materials, right. So, what are the instances? In telephones, cameras, button cells. In button cells, we can see substances like lithium and mercury. Now, mercury is a type of heavy metal, right? And instances, wristwatches, calculators, etc. We can see these button cells. And the next one, lead acid accumulator or car battery. Why do we call it lead acid accumulator? Because it is made out of lead plates and dilute sulfuric acid. Now, lead is also a type of heavy metal, right? So, instances in cars, buses, motorcycles and in rechargeable electric torches, we can use these type of batteries. Okay. So, there's another important thing that you have to learn. For your special attention, batteries and cells disposed after use should be directed for recycling without throwing them to the environment. Why? What is the reason? Now, there are some chemical substances that are really harmful for organisms. What are they? You can see here mercury present and lead present. All these substances are very harmful. What will happen without recycling these type of cells and batteries? If we just throw them into the environment, what will happen? These harmful chemicals will get added to the environment. They will get added to the waterways. Lead, mercury-like substances, when they get added to the waterways, even if we boil this water when we drink, these harmful substances will not get destroyed. So, what will happen, children? When we drink this water, these harmful chemicals will accumulate or they will collect in our bodies and we will get different diseases like kidney diseases and cancers. Same harmful effect will happen to the animals as well. So, that is why we should not dispose them into the environment. You have to collect them and recycle them. I hope this part is very clear now.